Hey guys, welcome to the Pre-Calc Unit 6 Review Video Answer Key. All right, let's get started right here. Number 1, factor the following polynomials. We want to try factor by grouping. And the question is, can we do two groups of 2? And at first glance, it looks like you can take out a GCF here. Take out an A and you have an A minus 8B. But there's no way you can get another A minus 8B from this. There's no GCF there. So I either need to do a group of 3 and 1, or a group of 1 and 3. This first trinomial factors nicely. Two sets of parentheses, you have A and A, signs are the same, both negative. Factors of 16b squared would be 4b and 4b. Now I want to write that as A minus 4b squared, and then bring down your minus 25. So what this really is A squared minus b squared, right? You have two sets of parentheses, you have A plus b and you have A minus b. So two sets of parentheses, one's plus, one's minus. The square root of the first term is simply A minus 4b. So I put that in both. And the square root of 25 is 5. So you can leave your answer like this, or if you want to get rid of those parentheses, it would simply be A minus 4b plus 5 times A minus 4b minus 5. All right, our next one is more familiar to us because I can do two groups of 2 here. And the first group, I'm going to take out a 2x squared, and I'm left with x minus 5. So in order for this to work, I know I need an x minus 5 in that second group. So I'm looking at this, and yeah, we can take out a 9. So now the GCF is x minus 5. I'm going to take this out of both, and that's going to become a factor. So I have x minus 5, and then what's left in my other factor is what I have left when I divide that out, which is 2x squared plus 9. Okay, so now we're starting to get into the conic section questions. It says find the vertex, focus, and equation of the directrix for the parabola. Now, I prefer to move this over here with the x. So this equation is going to look like x minus 7 equals 1/16 times y minus 5 squared. Just because for me this looks a little bit more consistent with our other conic section equations. Now I can identify that vertex easily. It's going to be the opposite of what's with the 7. Or sorry, what's with the x. So that's 7, comma, the opposite of what's with the y. So that's 5. There's your vertex. Now the next thing you need to understand or memorize is that if your equation is x equals y squared, what does that parabola look like? Does it open up, right, down, or left? Well, an x equals y squared opens to the right. So I'm going to make a quick sketch here, what that parabola would look like. And I know this is my vertex right here at 7, 5. Now you want to visualize, where is the focus going to be? Well, the focus is going to be inside that parabola, so right there. How about the directrix? Well, it's going to be a vertical line out here. I don't know the coordinates of either one of those. I know this vertical line has to be x equals something because it's vertical. And what we need to do next is we need to calculate that distance we call p. So this is a formula you have to have memorized for parabolas. P equals 1 over 4a. And in this equation, a is 1/16. So that's going to be 1 over 4 times 1/16. That's 1 over 1/4, which equals 4. So this distance here is 4. And that distance there is 4. So to get the coordinates of the focus, one thing you know, it has the same y value as the center, because it's on the same horizontal, so the y value is 5. And how do you get the x coordinate? Well, you know this is 7, and that's 4, so this x coordinate is simply 7 plus 4, or 11. Now you can make a more accurate sketch if you wanted to, but as long as you understand the concept and where f is in relation to the vertex, you can just add those two numbers. Now for the equation of the directrix, I need to go this way 4, from 7, so this is going to be 7 minus 4, or x equals 3. So my directrix, x equals 3. All right, the next one, write the equation of a circle, center 4, -1, and radius equals 7 in general form. Probably see one of these on the exam. You have to watch out for that. General form is kind of a pain because we have to multiply everything out. Getting the standard form equation for this is pretty simple. X minus 4 squared plus y plus 1 squared equals 49. So what I need to do now, multiply all this out. And you have to subtract 49 over to this side so it's equal to 0. So I'll just go through this process quickly. Multiplying x minus 4 times x minus 4 gives you x squared minus 8x plus 16. Y plus 1 times y plus 1 will give you y squared plus 2y plus 1 minus 49. Now we just have to combine everything and put it in the general form order. We start with an x squared, then we list the y squared, then our x term, then our y term, and then I take 16 plus 1 minus 49, and that gives me negative 32. And don't forget, that equals 0. So not too bad. It's just more of a lesson in algebra. Okay, now we get to some challenging questions here. I want to write the equation of an ellipse given the foci are 1, 5, and 1, 9, and has a major axis of length 10. So the first thing I'm going to do is make a quick sketch. 1, 5, 1, 2, 3, 4, 5. That is a focus. And 1, 9, 6, 7, 8, 9. There's another focus. So there are my two foci. What I would do next is I would find the center. You can use a midpoint formula from geometry, but these coordinates are easy enough. And if you sketch it neat enough, it's pretty easy to see. Well, my center is going to be 1, 7. And it's an ellipse. So I know because my foci are on the same vertical that my ellipse will look something like this. So the y pole is going to be greater than the x pole. And I know the center is 1, 7. I can start writing this equation. X minus 1 squared over something plus y minus 7 squared over something equals 1. This will be my final equation. Now, what goes where? Underneath here will be your x pole squared, and underneath here will be the y pole squared. Now, unfortunately, I don't know either one of those right now because they give me the foci. Those are the hardest points to come up with your equation from. But they did tell us the major axis has a length of 10. So since my ellipse will look like this, my major axis is going to be vertical. So that's going to give me my y pole. And in this case, my y pole equals 5. Because remember, the entire length is 10. So this will be 5 squared, 25. Now, how do I get the x pole? They don't give me any other information other than the foci. Well, remember, when I give you the foci, it's kind of small here, but you know the value of c. In this case, c is going to equal 2. I need to know my c squared equation for an ellipse. It's c squared equals a squared minus b squared. So I have 2 squared equals, now we also need to understand that since my ellipse is vertical, the y pole is greater, so the y pole is going to be your a value. So that means a equals 5. So this will be 5 squared minus b squared. Okay, 4 equals 25 minus b squared. Subtract 25, negative 21 equals negative b squared. 21 equals b squared, and that's all you need. I'm not graphing this. I don't need the x pole. 21 will go right there. And there's your equation. Next, given the foci again and the transverse axis length of 8, find the equation of the hyperbola. So as neatly as I can, I'll make a sketch here. 2, 1, that is a focus, and 12, 1. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. There's another focus. Well, like I did up above, I want to find the center. There's many ways you can do it. I give you easy coordinates. You can take 2 and 12, add them together, divide by 2, that gives you 7. You could take the distance between these, which is 10, divide that by 2, and that's 5, and just go 5 in one direction. I don't care. It's pretty straightforward. You need to get 7, 1 for your center. 1, 2, 3, 4, 5, 6, 7. Now, the other thing you want to realize is that since my foci are on the same horizontal, that my hyperbola will look like this. Because it looks like that, it's going to be x squared minus y squared. And we know the center, so we can start writing our equation. X minus 7 squared over something minus y minus 1 squared over something equals 1, just like we did up above. Underneath here will be the x pole squared, and underneath here will be the y pole squared. Now again, I can't get either one of those from the foci, but it tells me here I have a transverse axis length of 8. So the transverse axis, I'm going to make a quick sketch here. That's what your hyperbola is going to look like. The transverse axis is the distance from vertex to vertex. That distance is 8. But remember, that's not this. This is telling me my x-pole, sorry, a little bit too far. My x-pole is going to be 4, half of that 8. So this is 4 squared, 16. Okay, well, how do I get the y-pole? Well, like we did up above, we need to use a c-squared formula. C squared equals a squared plus b squared for a hyperbola. And what do we know about c? The distance from here to here is 5. So this will give me 5 squared equals, and now again, we need to know our a and the b. In a hyperbola, a is always under the first term, so a is going to be 4 in this case. Not that it really matters because we're adding. So this will be 25 equals 16 plus b squared. Subtract 16, 9 equals b squared. And again, I don't really need to know what b is. I just need the equation, so I put a 9 there, and I'm good to go. Okay, next one. Couple application problems now. Car headlight in the shape of a parabola. The width of the headlight is 9 and is 4 inches deep. Find the exact location of the bulb to the nearest 100th inch. Remember the reflective properties of a parabola. Anything emitted from the focus comes out parallel. So here's my light. The width would be across the lens, that's 9 inches. The depth would be from the lens to the back, that's 4 inches. And I want to know where to put the bulb. That'll be at the focus. It's kind of like an engineering problem. What I want to do is I want to take that physical representation of the light bulb and put it, or the headlight rather, and put it on a coordinate plane. And the easiest way to do that is to put the vertex at 0, 0 and have the parabola open up. So what I'm doing here is making a cross section of this headlight. And what I know is that the width is 9 and the depth is 4. All right, well, what is the equation of this parabola right here? That's what I need to get. The vertex is at 0, 0. It opens up, so that equation is y equals ax squared. But I don't know what a is. To help me get a, I need to find the coordinates of this point right here. Well, if this width is 9, half of that would be 4.5. So that's what the x coordinate is going to be. And this height right here is your y value, so that would be 4. So I've got 4.5 comma 4. Why is that helpful? Because this is x, this is y. So instead of x here, I'll put 4.5. Instead of y there, I'll put a 4, and I'll solve that equation. So 4 equals a times 4.5 squared. A equals 4 divided by 4.5 squared. This is all calculator active. If I do that, I got 0.1975 to 4 places. So that's great. I got A. But what does that do for me? Well, remember, the bulb is going to be at the focus. The distance from the focus to the vertex is what we call P, and then we had this formula, P equals 1 over 4A. So now I can calculate this. 1 over 4 times 0.1975, that's 1.27. So remember what that 1.27 represents. It represents the distance from the focus to the vertex. So that distance right there is 1.27 inches. The distance from the back of the headlight to the focus is 1.27 inches. Well, we just need to describe where to put it. I would say something like place the bulb 1.27 inches from the back of the headlight. And then maybe in parentheses you say vertex, because that's what it is. It's the vertex of that parabola. All right, our next application problem is an ellipse. It says describe the location to the nearest hundredth of the foci of the ellipse pictured below. So where are they going to be? In general, here and here. But what do we need to find? Well, we need to kind of understand where they are in relation to my center. I need to find this, which is C. Well, it's an ellipse. I've got a c-squared equation. I know c squared equals a squared minus b squared for an ellipse. But we've got to be careful. We're not going to use 20 and 10 in that formula. So if I sketch this out again, that's my a value right there. That's the major pole. A equals 10. There's my b value, the minor pole. B equals 5. So in this equation, I'm going to get 10 squared minus 5 squared, which ends up being 75. Square root both sides, c equals 8.66 to the nearest hundredth. Now again, I haven't answered the question. I found a number, but you have to describe where to place the foci, or where they are. So I would say something like the foci are 8.66 inches from the center and on the major axis. So you have to mention both of those things. The distance from the center and where to put it, so it's not just a circle anywhere around that center. It has to be on the major axis, 8.66 inches away. All right, so now we get to the tough problems here. Sketch the ellipse, labeling the center, the foci, and the endpoints of the major and minor axes, lateral rectum, and find its eccentricity. So we got a lot to do. First thing I'm going to do is group my terms, because obviously I need to get that from general form into standard form. So I'll start by taking my x's over here, 16x squared plus 64x. Give yourself a little room. Plus 9y squared minus 54y. And then don't forget, do the simple stuff. We're subtracting 1 from both sides. So if I want this to go to the other side, it's got to be negative 1. Now I take out a GCF. So take out a 16 here. That gives me x squared plus 4x in parentheses. Take out a 9 here. That gives me y squared minus 6y equals negative 1. So if I complete the square with the x's, half of 4 is 2. 2 squared is 4. But remember, you're not really adding 4. You're adding 16 times 4, 64 to both sides. So over here, I'm going to add 64. Complete the square on the y's. Half of 6 is 3. 3 squared is 9. Adding 9, but you're not really adding 9. You're adding 9 times 9, or 81. So I have to add 81 to the other side. Now let's factor. 16 times x plus 2 squared plus 9 times y minus 3 squared equals negative 1 plus 64 plus 81 is 144. And lastly, I divide by 144. If these numbers get bigger, remember on the exam, everything is calculator active. So this will give me x plus 2 squared over 9. If I divide that out, this will give me y minus 3 squared over 16 equals 1. There's my standard form equation. From this, right away, should be conditioned by now, center, x pole, y pole. Okay, so my center will be negative 2, 3. X pole equals 3. Y pole equals 4. Now, in this case, in an ellipse, remember, your a value is the larger of the two. This will come into play when we have to find eccentricity, maybe with our c-squared equation, and b would be 3. Let's make a sketch. So if my center is negative 2, 3, generally what we want to do here is kind of make sure that point negative 2, 3 is somewhere in the middle. So I'm going to adjust my axes a little bit. You know, we have an option of putting those in. So I'm going to put my y-axis a little bit more to the right. So there's y, and since my x value, or sorry, my y value is 3, I'm going to make my x-axis a little bit lower, somewhere around here. You don't have to do this, it just makes it easier. Now that I have my axes labeled, I will plot the center, which is negative 2, 3. X pull is 3, so 3 to the right, 3 to the left. Y pull is 4, up 4, down 4. And since I have to find the lateral recta for this, I'm going to wait to sketch this in because I'm going to need other coordinates. But I do know since the y pull is bigger, this is a vertical ellipse, if you will. So these are my vertices. I can label those right now. This is V1 and that's V2. Let's get those coordinates. V1 and V2. You can get those right from the grid. Coordinates of V1 are negative 2 and 1, 2, 3, 4, 5, 6, 7. V2 is negative 2, negative 1. Those are coordinates you always have to identify. Now let's get the foci. So foci, c squared equals a squared minus b squared for an ellipse. C squared equals 16 minus 9, that's 7. So c equals square root 7. Ballpark square root 7 is about like 2.6. So to plot these points accurately, I have to go 2.6 from the center. 1, 2, so it's about right there. That would be F1. And then down 1, 2, and about there, there's F2. What are those coordinates? Well, F1 and F2. Now there's going to be a radical involved. Simplest radical form, that's square root 7. This distance here is square root 7. Square root 7. Notice the nice thing, once you've established the vertices, is that the foci and the vertices are all on the same line. In this case, they're all going to have the same x value. So they'll have the same x value as those vertices, negative 2 comma something. And how do you get that coordinate, the y coordinate? Remember, you take the center y value and you add square root 7 to get to F1. To get to F2, you subtract square root 7. So this will be 3 plus square root 7, and this will be 3 minus square root 7. All right, so now, eccentricity, I'll get that in a second. Latera recta. This is where you have to remember the LR pull equals b squared over a, and why it's important that you know a and b. So in this case, b is 3, b squared will be 9, a is 4, 9/4 is simply 2.25. So the distance from the focus to the LR is 2.25. And I can plot that fairly accurately. So let's do that. So 1, 2, about right there, and 1, 2, about right there. So this will be L1, this will be L2. And then from this focus, 1.25 is about right there, 2.25. So now, my ellipse, let's label this L3 and L4. My ellipse has to go through all of these points. So right now you can see it's pretty easy to make an accurate sketch. Goes through all of those. Okay, so now I need to come up with those coordinates. All right, now notice how these are arranged here, and I'm going to arrange them the same way down here. So I'll do L1, I'll do L2, L3, and L4. So L1 and L2, they're on the same horizontal as the focus, so they will have the same y coordinate as F1. All right, so that's going to go here and here. 3 plus square root 7, 3 plus square root 7. To get the x coordinate, you have to remember what we did is we took this x coordinate here and I basically subtracted 2.25 going that way. So if this is a negative 2, I subtract 2.25, that's going to be negative 4.25. To get this x coordinate, I take this and I add 2.25. So I'm at a negative 2 plus 2.25 is 0.25. And now all the hard work is done, because you know these two down here have the same y-coordinate as f2, so 3 minus square root 7. And L1 and L3 have the same x-coordinate. So those will be the same, negative 4.25. And then obviously L2 and L4 have the same x-coordinate, so those two will be the same, 0.25. And lastly, finally, we get to eccentricity. That is C over A. C is square root 7. A from up above is 4. And it doesn't specify, but usually they want like to nearest thousandth. So if you divide that out, you get 0.661. All right, whew, that was tough. This one will be a little bit easier. We're given a hyperbola in standard form. It says label the vertices, foci, equations of the asymptote lines. All right. First thing, before I even get to that, notice our standard form equation. It's a y squared minus x squared. So that means my hyperbola is an up-down hyperbola. Okay, keep that in mind. So now my center is going to be, remember, the opposite of what's with the x comes first. So 5 comma negative 3. X pole is always underneath the x. So x pole is going to be 9. Y pole is always under the y. That's going to be 5. Okay, so like I did before, my center is 5, negative 3. I'd like the center to be approximately here. And maybe what you want to do is put that point in and then make sure that that's 5, negative 3. So you adjust your axes like so. Doesn't really matter. I'm just going to sketch in my axes first. So I'm going to move up my x-axis a little bit. And I'm going to move my y-axis to the left a little bit. So make sure you establish those. So 5, negative 3. 1, 2, 3, 4, 5. 1, 2, 3. Right there. That's going to be the center. The x-pole is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have to go off the grid a little bit, that's fine. Just put a couple tick marks there. Y pole is 5. 1, 2, 3, 4, 5, and down 5. Right there. So now once you've established those coordinates, next thing we're going to do is make our rectangle. Remember, use a dashed or dotted line to do this. Now, the diagonals of this will be your asymptote lines. Sometimes it's helpful to have a straight edge here. I'm going to try and do this freehand, so bear with me. Probably won't be the greatest. Okay, now this is where our little thumbnail comes in handy, because it reminds you, like, oh yeah, it's an up-down. Now, our asymptotes here are really wide, so when I sketch this in, this is going to be super wide. It's going to look like this. So obviously that's going to make these coordinates right here my vertices. So there's V1, that'll be V2, and I'm just going to kind of sketch it in as well as I can, approaching those asymptotes. All right, so now I've got some information. I already labeled the center. I can now get the coordinates of V1 and V2. All right, V1 is going to be 5, 2, looking at that graph, and V2 will have the same x-coordinate, 5, that's going to be negative 8. So I've got those coordinates. Next, I want the equation of the asymptote lines, which is pretty easy because you get the equation of the lines right from this. It's going to be y plus 3 equals plus or minus my slope times x minus 5. So y plus 3 equals plus or minus my slope times x minus 5. Don't forget your slope is y pole over x pole, right? Delta y over delta x, change in y over change in x, rise over run. I don't care if you simplify it or not. In this case, there's nothing to simplify, though. It would be 5 over 9, but that's fine. You don't have to simplify it, even if you could. Okay, so now I need the foci. And for hyperbola, c squared equals a squared plus b squared. Okay, so c squared equals 81 plus 25, that's 106. So c equals the square root of 106, which is approximately 10 point something. So to put that in my graph, I have to go up 10 point something. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm off the graph. F1 will be up there somewhere. And then down 10 point something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between 10 and 11, there's F2. So how do we get those coordinates? Well, remember, it's all about a pattern, right? You know the distance from the center to the focus is square root 106. So basically what I'm doing is I'm taking this y coordinate and I'm adding square root 106 to it. All right, the x coordinate is going to be the same as the vertices, same as the center. That's 5. My y coordinate from the center is -3 plus square root 106. And then F2 would be 5 comma -3 minus square root 106. And then finally here, eccentricity. Doesn't specify eccentricity, does it? No, it doesn't say find eccentricity. I'm going to, because you might have to tomorrow on the exam anyway. So C over A. C is square root 106. A in this case, you have to be careful. Because remember, A is always under the positive one. That's an A squared and that's a B squared. So your A value is going to be 5. That's where it gets a little bit tricky. So this would be over 5. I don't have my calculator handy, so I'll just leave it in a ratio. Okay, last one. It's not easy either. What type of conic section? Write the type of conic section, put it into standard form, and identify all key information. So because you notice signs are the same and both of those are equal, it's going to be a circle. I need to get this into standard form. First thing I would probably do is divide off that 2. Make the terms easier to work with. X squared plus y squared plus 16x minus 7y plus 4 equals 0. Now let's group our terms. X squared plus 16x plus y squared minus 7y equals -4. Remember, do the simple stuff right. Subtract 4 over to the other side. Let's complete the square. On the x's, easy. Half of 16 is 8. 8 squared is 64. Let's add 64 to both sides. Next, complete the square on the y. Half of 7 is 7 over 2, 3.5, and I have to square it. Now, it's calc active, so you can do that in the calculator and get the decimal, but let's say it's calc inactive. Take half of it and square it. Okay, so I have to add 7 halves squared. I don't really care what that is on this side. On the other side, though, I do need to know what that is. So we'll say it's 49 over 4. So now factoring over here, I get x plus 8 squared plus y minus, well, that'd be 7 halves squared, so that's not too bad, equals, well, here I have to do a little bit of work. All right, I know 49 fourths is the same as 12 1/4. So this here would give me 60 plus 12.25, so this would be 72.25. All right, I can get that far without a calculator, and that's pretty much the end of the line. I can get the center easily, but not the radius. So it's a circle. Here's your standard form equation. And my center will be -8, comma 7 halves, or 3.5. And my radius will be square root of 72.25, which is 8.5. All right, guys, that concludes the video key for Unit 6. Please reach out if you have any questions. Thanks a lot for watching.